are also able to do these other tasks. And I assume that when you are able to do this, you are also able to do that. So if anybody is able to look at this picture and say a group of people playing a game of frisbee, I'll assume, man, they should be able to, look at this and say a traffic sign with, which has been, defaced. Or look at this and say it's a car which is like a rabbit. Except in these cases, a refrigerator filled with lots of food and drinks. You would not have a human being who knows how to label this correctly and not this. So you have no understanding as to what the limitations of the system you are playing with are. That's a huge, huge thing, because you can be in big trouble in actually having any kind of a guarantee on what the system is doing. And I want to show you a few more things about that. But before that, so neural nets basically are very, very impressive in doing image recognition. But really, are they seeing the world the way humans do? Let's start off what you think, because we are mostly looking at image recognition. Okay. Okay. So let me tell you about spexiousness. It's late in the day, but you should know about this really amazing bug called the Spex. Spex is this bug which essentially takes smaller bugs and it stuns them with poison, and then it just drags them to its home. Not just that, when it goes to the home, it leaves the stunned bug outside, goes inside the home, checks around to see everything is fine, then comes out and takes the stunned bug and takes it and stores it. Some of you, I know some undergrads who sound less intelligent than Spex the bug, right? The question is Spex really so darn impressive? This is doing something which is involving cyber security of sorts, right? It's checking whether there are some enemies inside, and it's checking and coming back at it. Beautiful stuff. But is it really? So some psychologists, some entomologists who basically have no job whatsoever started playing with Spex. So you want to say you're so intelligent, hey, let's see this following thing. So when this guy went in, he took the stunned bug, put it outside, went into the home, and before it came back, this entomologist pushed the bug a little bit, 3 millimeters. Then what does the Spex do? It comes, takes the bug, puts it in the right place, goes back into the home, checks everything, comes back. At which point the entomologist again puts it by 1 millimeter, it again puts it back, goes back, and comes back. If you see this, you think, oh my God, this is not a bug that I'm going to have as a pet bug. It looks like a stupid bug. Do you see what I'm saying? Apparently intelligent behavior is not intelligent at all, because people who do this sort of a thing will do lots of other things, and so you're assuming this bug is pretty darn impressive bug, and it's a stupid bug. It's actually a deterministic bug. Okay, now the example closure and the spexiousness of the networks collides, and so this is a school bus. You give this to the network, it says it's not a school bus. I'm talking about the network that's been trained by Zagardi et al. In 2014. That's the Google guys who won the image recognition competition. They gave this, it will say, yeah, school bus. You give this, it says, no, not at all a school bus. Slightly ballistic. On the other hand, it says, this is darn school bus. This is a pretty darn good school bus. So sometimes talking more makes people realize how stupid you are, right? If it just stopped after this, you say, wow, what an amazing system. Oh, I don't know, maybe something wrong with this. But this is school bus? But that's what happens. Okay. Now, here is a zoo. Here is a zoo of animals. This is a robin. Do you see the robin? Cheetah, armadillo, lesser panda, centipede, peacock, jackfruit. This is actually it. And bubble. So imagine, so imagine having this guy on your car, basically trying to figure out, hey, there's a jackfruit on the road, get out of the road. Then you eat the jackfruit, that's a different story. But now the interesting thing is, neural networks, you think, are able to figure out all these 1,000 classes of the object the same way you figure out. All they are figuring out is that this thing is closer to the Robin class than the other 999 classes. That's all it's saying. That's very sad. Because it's not sad because of neural network, it's sad because of you. Because you think neural network which can do that school bus should not be thinking that at all that these are school buses, and definitely should not be thinking of these as cheetahs and albatrosses. This is 2014. I want to show you, and of course these are other things. Pink penguin, starfish. Wow, this thing does look like a starfish, right? It's sort of Matisse starfish. This is baseball. I guess you can see the baseball there. I don't know. African grey, electric guitar, etc. The point I'm trying to make is this idea of example closure. You think that if somebody can tell one cheetah, they can tell the other cheetah, except that they're also saying, yeah, this is also a cheetah. Then you wish they didn't speak after the first cheetah, because now you know they're stupid. Okay. Here, this one is seen to be a train, actually a train compartment, and that's because essentially it trained on this, and if you remove most of it and just keep this piece, it still sees it as a train. Now you can say, wow, that's like a feature, not a bug. But if you start seeing these as trains, people will say you're hallucinating, and what drug are you taking? Okay, this is the best I like. So there is this. What do you think this is? What? Come on, have you guys gone to zoos? What is this? Panda. What is this? Rorschach test. I add this to this. What do you get? Same thing. You all say it's panda, right? Original image is classified by Slegadi's network, actually this paper, as with 60% confidence is a panda. After this little bit of noise, it's classified as 99% confident gibbon. If you know what gibbons are, then it's very different looking than a panda. You don't see a gibbon there, unless you don't know what gibbon is. And yet, the machine essentially says it's a gibbon. So imagine, basically what is happening is they're finding some classification and they're doing okay on some particular examples, but you can easily find examples that show their misunderstanding. Unfortunately, that's what I did with those 10 marks, 10 questions in part B. Unfortunately, because all of you think you know what's going on with A-star search, but as soon as I start making you write sentences, I say, oh my God, this is what you think A-star search is? You get 0. If you speak true or false and don't say anything, I would think you're all brilliant. The more you talk, it is possible that you're really brilliant. It's also possible that you're opening yourself up for being shown to be not brilliant. That's what happened to this poor neural network. More importantly, what's happening is this sort of a thing can be used essentially in an adversarial framework. People know that your car basically has one of these Google networks, so they can do adversarial imaging and then make the car start hallucinating stuff that doesn't exist. You're talking about hot wiring computers. You're going to have hot wiring of these autonomous cars. The problem is, essentially, we don't. I get it. The problem is that even though you don't see any difference between this and this, the stupid neural network seems to be seeing a big difference. So that it's going from 60% confidence panda to 99% confidence gibbon. Just as you feel much more superior to the neural networks, I show that to you, which most of you know, right? I'm actually going to do my own question. So, how many people see this as blue dress with black? Okay. So those of you who saw that, now I'm going to ask the other guys, how many of you see this as what? White with golden brocade?
No.
The rest of you, do you see that those people are obviously hallucinating, right? And yet, of course, it turns out that human eye is very much fallible. It's a fallible in a slightly different way. It doesn't see gibbons where there are pandas. It does do this. Okay, so of course this was like a huge big sensation on the Twitter last year, right? And first you did see, you guys can, while going back, basically gang up on these people who seem to be seeing this when it is this, right? But all they're doing is playing with the background lighting, and then you see the background lighting, our brain starts viewing it as a different way. So there are two very different points I'm making. One is, of course, neural networks are actually not just because they can recognize something, they are not like human beings that recognize the same thing. And second, if you take it to the extreme, people are also probably not sure what they are actually recognizing. But that's a much farther down point. But I'll basically stop there, I guess, and then basically point out that one of the big things that people are talking about is how to get neural networks to explain why they are seeing gibbets, why they are seeing patterns, and basically provide some sort of reasoning about that.